This is paper 1, June 2010. Question 1. Write the number 14,523 in figures. So 14 for the 1,000 and then just 523 after that. Write the number, that's 50,000 in words, so you just write 50,000. Write down the value of the figure 7 in the number 5,768. The value of it means whether it's worth units, tens, hundreds or thousands. After the 7 I said 100, 5 is thousands, 700, 60, so that's 60, and then 8 is your units. So the 7 is worth 700 or hundreds. You would get the mark for writing either one of those. Write this number to the nearest 10. So the 10s are at the end there. So 81, it's closer to 80 than what it is to 90. So the 5,200 stays as it is, and then just change the 81 to 80 at the end. The nearest 100, those are your hundreds, 283, it's over halfway, so it's closer to 300. So the 5,000 stays as it is, and that goes to 300. Write 1,000 as a power of 10 means 10 to the power of something, and it would be 10 to the power of 3, 10 cubed, because that means 10 times 10 times 10, which is where 1,000 comes from. So 10 cubed for your answer for that one. Number 2, the scale shows the probability that 3 events A, B and C will happen. Choose the correct word to complete each statement. So event A, it would be very unlikely that it would happen. Unlikely would maybe be about here somewhere. So that would be very unlikely. Then event B, it is past halfway, so it's more than, well, there is no evens there. So it would be more than halfway, so it would be likely there. Not very likely would be further on up the scale somewhere. And C is right at the end, so it is certain. So very unlikely, likely, and then certain. Number 3, on the circles draw a radius and an arc. So a radius is a line just going from the middle of the circle out to the circumference of the circle. So that's your radius. The diameter goes the whole way across. Radius is a shorter word, so it's the shorter line. Then the next one you're asked to draw an arc. An arc is a bit like an arch, like an archway that you'd get in a doorway or a bridge or something like that. It's just a wee bit of the circumference. You can draw it anywhere you like. I just drew it at the top there so that it makes it look a bit like an archway that you get in a bridge or something. Complete the sentences. The shaded area there is a sector. It's like a slice of pie. So remember the C in slice and the C in sector. Whereas that would have been the shaded in bit. That's a segment. So sector, segment. Then the straight line, this line here, it is called a chord. The chord is the line that separates the circle into 2 segments. So yes, that's a segment, but that line there is called a chord. The one that didn't really come up there, well, there were 2. Circumference is the one around the outside of the circle, and another one that didn't come up was tangent. A tangent is outside of the circle, just touches it and then goes away off. So they didn't ask you for it in those questions, but just covering that since we're on circles. Number 4, complete the table by putting each of the following numbers in the correct box. So the first one was to do with odd numbers. So if you go along and pick out the odd numbers, or anything ending in 1, 3, 5, 7, 9. So the odd numbers are those 2 there at the end. So they have to go either here or here. 49 is a square number because it's the answer to 7 times 7. And then 125 is a multiple of 5 because it's in your 5 times tables. It ends in 5, so it's in your 5 times tables. So that's those 2 done. Factors of 20 next. So those are numbers that you can divide into 20. So numbers that 20 divides by. So that's those 2, 4 and 10. So one of them's a square number and one of them's a multiple of 5. So 4 is a square number because it's the answer to 2 times 2. And then 10 is the one that's a multiple of 5 because it's in your 5 times tables. The last one's then your multiples of 6. It's obviously these 2 that we've got left over. Multiples of 6 are numbers in your 6 times tables. So that's those 2. The one that is the square number is 36 because it's the answer to 6 times 6. And then 30 is a multiple of 5 because it's in your 5 times tables. So your square numbers, it's whenever you do something like 7 times 7, 2 times 2, 6 times 6. It's the answer you get whenever you times a number by itself. Number 5. The first 3 odd numbers are 1, 3, 5. Write down the 4th odd number. So the next odd number after that would be 7. Then the 10th odd number, I just went up in odd numbers until I got to the 10th one. So that was 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. I left one out. 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. Yeah, left one out. So it should be 21 for your answer there, not 19. So 21. It's a good job I counted those again. Then part B, show how you could find the 100th odd number without writing down a list. I used something called the nth term, but I'm not sure if you would even think about doing that there. The 100th odd number, every other number is odd. So if you're going along missing a number out, that means that you would be multiplying by 2 because you're using one then missing it, then using one then missing it. And then you would need to take away 1 because if you just keep going along multiplying by 2, you would end up just with your even numbers. So to get to an odd number, you'd have to take away 1. So the 100th odd number, 100 times 2 would get you 200. So 200 is the 100th even number. And then take away 1 means that 199 would be the 100th odd number. It's quite hard to explain. Not sure if I did a very good job of that. The other way to do it is this, using the nth term, but I'm not sure if you would even, as I said, I'm not sure if you would even notice how to do that. So the 100th odd number, just multiply by 2 and then take away 1. Then number 6, Kerry, or whatever way you say that name, Sherry, finds these distance measurements in an old mathematics textbook. Use the table to find the number of yards there are in 1 mile. So you're wanting to go right from mile right the way up to yards. So 1 mile is 8 furlongs. So I wrote that down first. 1 mile is 8 furlongs. And then you're told here that 1 furlong is 10 chains. So then 8 furlongs would be 8 of these, which would be 8 of those 10. So 8 times 10 would get you 80 chains. And then you're told that each chain is 22 yards. So then 80 chains would be 80 of these, so it would be 80 22s. So 80 times 22, but you don't have a calculator. So down here I did 22 times 8. So 8 2s are 16, 8 2s are 16 again, plus the 1 17. And then if that's the answer to 22 times 8, 22 times 80 would just be 10 times bigger than that, so just stick a naught on at the end. Number 7, you have a calendar for May 2010, and then it picks out a wee bit of the calendar and multiplies those two numbers together to get you 33 and multiplies those two to get 44 and then takes them away to get the difference, and then it just asks you to do the same thing here. So do 5 times 13 is 65, should be able to do that in your head. And then 12 times 6 you might be able to do in your head as well, or else do a sum. And then subtract them. So 72 take away 65 will get you 7. Not a very difficult question. You just need to look through and work out what they're actually wanting you to do. They've even given you an example. So just multiply, and then subtract at the end to get the difference. Number 8. Again, another name that I can't say. Corin, possibly. Estimates the answer to 22 times 39. His answer is 800. Show how he could have obtained the answer. So he must have rounded 22 because it's in the tens to the nearest 10. So 22 rounds to 20, 39 rounds to 40, and then multiply them gets you 800. You do 2 times 4 gets you 8, and then stick the 2 noughts on at the end. Part B, estimate 596 divided by 31 and show you're working out. So because this number's in the hundreds, you round it to the nearest 100, which would be 600. And 31 is in the 10, so round it to the nearest 10, so it would round to 30. 600 divided by 30 without your calculator, I would take a naught off there and a naught off there and just do 60 divided by 3, get you 20 instead. And you do not need to go adding a naught back in there at the end. Once it's gone, it's gone. Right, number 9. The pie chart shows the destinations of 300 students from year 11 in 1980. Work out the percentage of students who went into employment. So percentages are out of 100. So if you add up what you've got there, so 20 plus 10 would get you 30, plus 25 would get you 55. So 55% so far. This must be another 45% to bring you up to the full 100. So all I've done down here is just show the calculations of where the 45% is coming from to make sure you get the 2 marks. Then the next bit, work out the number of students who went to college. So college is 20%. So that's 20% of 300 that we need to find. So to do that without a calculator, I would find 10% first. So 10% of 300, you just take a naught off. So 10% is 30, just take that naught off. And then to go from 10% to 20%, you double it. So 30 doubled gets you 60. So 60 is your answer for that one. The other way for you to find 20%, you could do something like find a fifth, divide by 5, because 20% is the same as a fifth. But I always stick to the same method of finding 10% first. Then part B, another pie chart, and this one is to do with 300 students again, but it's a bit more up to date. This is 2009, whereas the last one was 1980. So what was the most popular destination in 2009? Now the most popular destination is sixth form. And then it asks you, the pie chart shows the changes and destinations of the students, right down to changes that happened between 2009 or happened by 2009. So it used to be, don't know if I can get these two both on at the same time. Possibly, if I hold this up, this might not work. Kind of works-ish. So a couple of changes there. If you look at sixth form over here, it's only about a quarter, and then it's gone up a lot over in that one. So you could say that in 2009, more people are staying on to do sixth form. That's like doing A-levels, lower sixth, upper sixth. Then employment, it was a massive big slice in 1980, and it's gone down a lot. It's only at 20% now. So you could say that less people are going into employment, probably because more of them are staying on for sixth form, and also there's more of them staying on for college. Here was 20% and now it's up to 30%. Other has stayed the same. So the two things that you could say that sixth form went up, college went up, or employment went down. Or more people are going on to, or more people are staying on at school and doing sixth form or college rather than going into employment. Right, so number 10, here's a number sequence, work out the output. So just 8 times 9, 72, provided that you know your 8 and 9 times tables, that should be easy enough. If not, use your fingers. Here is a different number machine, work out the output. 100 take away 83 is just 17. Again, if you need to do a calculation, then do it. I just did it in my head. Then you've got 2 other number machines and you're given the input and output, and they want you to make up this bit here in the middle. And you had to multiply and then take away for this one. There's different answers here. I just did 9 times 2 would get me 18, and then 18 take away 7 would get me 11. That's not the only option. You could have multiplied 9 by 3 and then taken away something else to get you back down to 11, or 9 times 5 or whatever. I just chose the easiest one. I just multiplied by 2. Then 9 and 11 again, but we're adding and dividing this time. So you could do 9 plus 2 gets you 11, and then 11 divided by 1 gets you 11. But in previous years, I noticed most people didn't recognise that one. Probably because they didn't know that 11 divided by 1 gets you 11. But anyway, you could do 9 plus 13 gets you 22, and then divide that by 2 would get you 11. From what I can remember, most people would have been doing it that way. So just a mark for each of those. Number 11 is a conversion graph. So we're converting kilograms to pounds. So pounds are the old imperial units, and then kilograms are the new metric units. So use the graph to convert 5 kilograms to pounds. You just need to be careful that you're going to the right bit on the graph. So 5 kilograms. 5 kilograms would be down here at the bottom, and you rule up to the line, I was going to say best fit line, up to the conversion line and over, and it's sitting exactly halfway there between 10 and 12, so your first answer would be 11. Then the next one, you're changing 14 pounds back to kilograms. So pounds are up the side, go to 14, across to the line and down. And it's somewhere between 6 and 7, but you'd need to be accurate. It's exactly 2 wee squares past it. So you're going 6, 6.2, 6.4, 6.6, 6.8, 7. So 2 wee squares after it would be 6.4. The last bit then is the tricky bit. Use the graph to convert 40 kilograms to pounds and explain your method. The reason why this is difficult is just because 40 kilograms isn't on the graph, but there's a couple of different things that you could do here. 4 kilograms is on the graph, so you could go up and over and then times it by 10 to get 40, but I think that that number ends up quite awkward. It's not quite 9, so I maybe wouldn't use that one. You could use 10 kilograms because it goes right up to the top to 22. And then to get from 10 kilograms to 40 kilograms, you times by 4. So just times 22 by 4 to get 88. Or the option that I went for was the one that I'd already used. I'd already got up here that 5 kilograms is 11 pounds. And to go from 5 kilograms to 40 kilograms, you multiply by 8. So just do 11 times 8 is 88. So a few different ways there that you could do that. 2 or 3 different ways. Either way, you should be getting 88 for your answer. Number 12, the diagram shows a regular hexagon. So regular because all sides are the same length, hexagon because you've got 6 sides. By measuring the length of one side, work out the perimeter. So you just get your ruler, measure the length of one side and be accurate. It's just underneath 2, it's about 1.9, and then multiply that by 6. Although I think whenever I photocopied this, the paper shrunk a wee bit. I think in the actual exam it was exactly 2. So 2 times 6, you might have got 12 there for your answer. On the diagram above, draw in all the lines of symmetry. For your regular shapes, whatever amount of sides they've got, that's how many lines of symmetry they've got. So they would have, this shape would have a line going from corner to corner. So going corner to corner, corner to corner, corner to corner. And then it would also have them going from side to side. So going side to side, side to side, side to side. So those would be your 6 lines of symmetries going from corner to corner and from side to side. Watch out for wee questions like that stuck in. The amount of times that people leave them out because there's no actual lines for your working out and you just skip straight from here down to here and miss it out completely. So just make sure that you do all of the questions. Bit of an obvious one there. 3 regular hexagons are joined together as shown. So it's the same shape as what we had up above there, just 3 of them are joined together. Work out the size of an interior angle, so that's one of the ones on the inside of a regular hexagon, and you have to show you're working out. So for you to get the interior angle in here, you actually have to find the exterior angle first. And it is not actually going the whole way around the outside, the exterior angle is just that wee bit there. And you get it by doing 360 divided by your number of sides. So in triangles, the angles inside total up to 180. In quadrilaterals, inside totals up to 360. But then once you go beyond quadrilaterals, once you get to your pentagon, hexagon, octagon, decagon, it's not the inside that totals up to 360, it's the outside angles. So there are 6 sides there, which means there'd be 6 outside angles. So you do 360 divided by 6 gets you 60 for that one there on the outside. That's your exterior angle. And then your interior angle makes a 180 degree straight line with the 60. So the interior one would be 120. Just by doing 180 take away 60 equals 120. So you need to learn the 2 formulas, that your exterior is 360 divided by your number of sides, and your interior is 180 take away your exterior. You need to learn those 2 wee rules or formulas, whatever you want to call them. Number 13, ABC is a straight line. Ben says that angle X is 90 and we just want to show that he's wrong. So if X was 90, those 3 angles should total up to 180 because they're on a straight line. So total them up and see what you get. So 90 plus 70 plus 30 70 plus 30 is 100, and then another 90 is 190. So you've shown that he's wrong, because it's 190 that it totals up to, when it should be 180 for a straight line. Then write down the correct value of x. So the 70 plus 30 gets you 100, and then take it off 180 to show that angle x should actually be 80, not 90. So 80 for that one. Part B, the diagram shows a right angled triangle. Work out the value of y. So again, you need to know that triangles total up to 180, the same as the straight line. And this wee box down here, the right angle, is a 90-degree angle. So add up 90 and 65 gets you 155, and then take that away from 180 gets you 25. I haven't done any proper sums here because I thought the numbers were easy enough to do in my head, but if you need to do a calculation, do it. Number 14, Liz buys 3 cans of cola and the total cost is 165, and we want to work out the cost of 5 cans. So you would need to work out the price for 1 can here. It would be different if you were going from 3 cans to 6 cans or something. You could just double that price, but you're going from 3 to 5. So the easiest way would just be to go back down to 1 can and then up to 5. So do 165 divided by 3. So 3 into 1 doesn't go, carry the 1. 3 into 16 goes 5 times, that would get you 15, remainder 1. And then 3 into 15 goes 5 times. So 55p is the cost of 1 can of cola. And then you're wanting 5 cans, so just times that by 5. So 5 times 5 gets you 25, 5 times 5 gets you 25 again, but you've got that 2 to add on, so that gets you 27. And then be careful at the end, that doesn't mean that your answer is £275. Your answer is 275 pence, which is £2.75. Number 15, Jack has a box of 100 coloured discs, and they're either red, blue, green or yellow, and the table shows the probabilities or the chance of choosing a colour. Which colour disc is the most common? So it would be the one with the biggest probability, so that would be red, 0.6. Jack chooses a disc at random from the box. Work out the probability that he chooses a green one. Your probabilities always have to total up to 100%, or because these are decimals, they would have to total up to 1. So you've already got 0.6 plus 0.1 gets you 0.7, plus another 0.1 brings you up to 0.8. So then this last one must be 0.2 to bring you up to a total of 1. Or 1 take away and 0.8 gets you 0.2 would be the proper working out there. Write down the probability that he will choose a white disc. There are no white discs. It tells you up here that it's just red, blue, green and yellow, so the chance of you picking one out that's white, it ain't gonna happen, so not. Then part C, Jack says there must be 60 red discs in the box. Is he correct? And you have to give the reason for your answer. So he says that there's 60 red ones, so that would be 60, 10, 20 and 10, and that does total up to the 100 which they said was in it at the start, so yes, he is right. Or the other way to do it is to take the probability for red, take the 0.6, and if you multiply that by the 100 discs, that will tell you how many of the discs are red, and 0.6 times 100 gets you 60. So either answer there would be okay, either way that you do it. Then number 16, thought that was the last question there, I've got another one to go. Number 16, there are 600 people at a conference. A quarter of the people are in room 1, a third of the people are in room 2, and the rest of them are in room 3. How many people meet in conference room 3? So you need to find a quarter of 600 and then a third of 600 to see how many people are in these rooms. So a quarter of 600 is just 600 divided by 4. If you know that in your head, that's fine. I'm going to do a sum. So 4 into 6 goes once, remainder 2. 4 into 20 goes 5 times. 4 into 0, no times. So that's the quarter of the people. So that is room 1. And then this one is for room 2. So that's a third of the people. So a third of 600. Might be able to do that in your head. A third you just divide by 3. 3 into 6 goes 2, so 200. Then add those two together to see how many are in room 1 and room 2 all together. So 150 plus 200 is 350. And then you would need to take that off 600 to see how many are left for room 3. So again, if you can do that in your head, that's fine. I did a sum. So 0 take 0 will get you nothing. 0 take 5 you can't do. So stroke the 6 out, put it down to 5 and put the 0 up to 1. So then 10, or sorry, not the 0 up to 1, put the 0 up to 10 and then do 10 take away 5 will get you 5, 5 take away 3 will get you 2. So 250 are left for room 3. Last question then, number 17. The shape is a drawing of a house. Work out the area of this shape and state the units of your answer. So you've got two shapes there. At the bottom you've got a simple rectangle, and then at the top that shape is a trapezium. So you'll have to find the area of a trapezium and also the area of the rectangle. So the area of a trapezium, the formula for that is on the front of your paper. It's very dark there, you sort of see it. Half a plus b h, and it tells you that a and b are the parallel sides and h is the distance in between them. So just copy the formula over, half a plus b times h. So a plus b, that's the 8 and the 12, those are your parallel sides. So that is 8 and then that is 12. So you add those together to get you 20. Then you can either half it at this stage if you want, or else times it by the height first and then half it, it won't matter. So the height is just the distance between those two parallel lines, so that's 3. So you can do half of 20 gets you 10 and then times it by 3 gets you 30. Or you could do 20 times 3 gets you 60 and then half that gets you 30. It doesn't matter, either way you end up with 30. So that's the trapezium, that's the area of that bit is 30. And then the rectangle, to find the area inside the rectangle you just do length times width or base times height. So 12 times 6 is 72, and if you need to do a sum for that, do it. So that is that distance there, 72, and then the total area then will be the answer you get whenever you add those two together. So 30 plus 72 is 102. That'll get you 3 marks getting that far. But remember, it says state the units of your answer, and your units for area are always squared, and these are centimetres here, so it'll be centimetres squared at the end then. And that's that done. I don't quite know how this one has ended up as 27 minutes whenever all the other ones are about 40 minutes long. Not quite sure.